Hey everyone, it's John, and today we're going to continue back on the key concepts video series where I take some IP routing key concepts and break them down into a simple format to help supplement your textbooks. So in this video, what we're going to be discussing is OSPF, not so stubby areas. Now this sounds a bit ridiculous, but this actually is the name, and I think you'll find that it does kind of make sense when you follow it through. So with that said, let's kick on, let's do it. Okay, so let's go and draw it out then, shall we? So the topology is pretty similar to the previous ones, but you'll notice there's some distinct difference on the right hand side with this RIP network. We'll get to that in a second. First, just imagine that, as before, this EIGRP autonomous system number 51 is redistributing a lot of routes into OSPF, or rather the ASBR is redistributing all these EIGRP routes in, which is fine, and they're going to propagate out through the OSPF domain right through here. But let's say that we actually want to cut down on these E2 routes, and we want to do that in area 10. So we could do that. We could configure a stub, and as you know, a stub will effectively cut out these external routes and just replace them with a default and pretty much say, listen, give me all of the inter-area OSPF routes, but for everything else, just send it to a default. So effectively, this router here, if it wants to connect to some of the networks over here, it would just send it to the ABR, and the ABR would still have the full routing table to successfully route that traffic. This is all very well and fine. So where does the problem actually lie? Well, maybe you can guess by the diagram I've got here. Let's say that we want to remove all of these EIGRP routes, so we make this a stub. However, we are also connected now to a RIP network, which means that we're going to have to do some redistribution to allow connectivity. Well, that would mean that this router here would have to be an ASBR, and when it redistributes them, what's it going to do? It's going to redistribute them as type 5 LSAs. Now, what do we know about stub areas? Stub areas will not allow type 4 or type 5 LSAs within the area. So effectively, if we go to redistribute that in, we're pretty much going to say, nope, you can't do that. We're a stub, we will not accept type 5 LSAs. So then what's the choice we've got to make? Do we decide that we either can't redistribute this, i.e. we can't have connectivity to this network, or alternatively, we decide that, do you know what, we will allow connectivity, we'll put that in here, but we can't make this a stub, therefore we've got to accept all the routes from up here as well. How about we actually find a middle ground here? What we want is something that is a stub area that's going to cut out the E2 routes, the same as we had before, but make it so that it's not so stubby enough that it's going to also block these ones which are actually directly connected to our area. And this is where the not so stubby area comes in. Now, the way the not so stubby area is going to handle this, it's going to play a little bit of a trick, okay? And that trick is that when we configure the area as a not so stubby area, when we redistribute this ASBR is actually not going to send these in as type 5 because it knows that type 5 LSAs are not going to be accepted in any form of stub network at all, okay? So what it's actually going to do, it's going to say, do you know what, I'm going to redistribute these, but I'm going to actually put a little bit of a mask on them. I'm going to redistribute them as type 7 LSAs. Now this is the one we didn't talk about before, okay? So effectively we're going to bring in these external routes as type 7 LSAs so they can actually get into the stub network, and then once they hit the ABR here, this ABR is going to recognise them as type 7s, and I'm going to say, wait now, I know what I have to do with these. I have to actually convert these to type 5 now, so they go through this area as type 7s, so they're allowed because they're not type 5, but once they hit the boundary here, they're going to flip and change to type 5, and then all of these other, say for example this router here, it's just going to receive as a type 5 and it's just going to put it into its network as an E2. So this is how we're going to get around this problem. We're actually not going to be allowing in type 5 into our area, so we're still going to block this, but we're actually going to allow this one in because it's directly connected. So think about it this way, if the external network is directly connected to the stub area, i.e. this is right here, as the ABR is here, We can do this trick by pulling them in as type 7s and letting the ABR on the other side convert into type 5. Therefore, we can actually allow the traffic to be reachable through us, and we can still get our stub effect up here. So that is the basic broad theory of what a not so stubby area is. So what I think we should actually do now is actually look at the configurations, and we can see it because there's a few caveats we need to go through first. So with that, let's go and do some configurations, okay? So just clear this now, pull this down here, and we'll look at the configs. Okay, so let's go and do some configurations. Let's look at the routing table on router 10 here. So show IP route, and you can see we've still got all these E2 routes which we want to get rid of. So let's go and configure a stub first to remove them as we ordinarily would. So router OSPF 1 and area 10 stub. Set the stub flag here. Router OSPF 1 area 10 stub. Router OSPF 1 area 10 stub. Okay, so let's look at the effect. That should remove all those E2 routes and just leave us the inter-area OSPF routes, which is all good. We've cut down the routing table quite a lot there. So let's address this problem then. We're now going to try and redistribute these RIP networks in whilst we're still a stub network. So router OSPF 1, just full screen this, and do redistribute RIP subnets, and we're going to have a problem here. See that? Router is currently an ASBR, we're only having one area which is a stub. It's not going to be valid, it will not allow us, so just take that off and just do it in no. And what I'm going to do is do no area 10 stub, and do no area 10 stub. No, we're going to router OSPF first. Okay, and no area area 10 stub. My typing on this keyboard is absolutely abysmal. Okay, so what we're going to do now is configure a not so stubby area. So let's just do that all over again, but the correct way this time. So we're in router OSPF 1, just do that so you can see it. And what we're going to do is do area 10 not so stubby. Okay. Router OSPF 1 area 10 not so stubby area. And the last one, if we do router OSPF 1 area 10 not so stubby area. So now we've got this not so stubby area configured. Now let's try and do that redistribution this time. So router 14 is in trying to make it an ASBR, so let's redistribute RIP subnets. Seems to be okay this time. Let's go into our RIP process and do the same thing. So redistribute OSPF 1 metric and give it 2. Okay, so let's see how that looks now then. If we go to router 10, let's see if the loopback shows up that we've redistributed in from RIP. And it has, it's shown up as an N2 route, you see that? There's a loopback right there, and let's try and ping it. And let's see how that loopback looks from over here, okay? Might look a little bit different though. So if we do a show IP routes and just do an include 200, it's actually shown as an E2 over here, not an N2, and that is because it's only an N2 through the area 10, okay? Once it hits the ABR, like I say, it's going to flip and become a normal type 5. So all these other routers are going to see it as a type 5 LSA. So at first glance, this seems like a total win. Let's just check the routing table. Show IP route. We don't see any E2 routes. All those EIGRP ones are away, and we're allowing these RIP networks to come through. Here's the problem though. Let's go and have a look at one of the loopbacks on here. Just grab a random EIGRP route. So we'll just grab this one, all the 39s. And let's go to the router here and try and ping it. Uh-oh, we've got a bit of a problem here. And the problem is that when you configure a not so stubby area, that automatic default route, which the ABR would automatically generate a stub, does not happen. In the case of a not so stubby area, we're not going to make the assumption that you want to default out and go to the left here. this way, because you're actually connected to a different autonomous system, it's not going to make that decision and say, you're definitely going to go back to default into OSPF. It thinks you maybe want to go out to this autonomous system to your right here. So if you want to actually have that default route, what you need to do is, and if I just remove router OSPF1 and do no area 10 NSSA, okay, to the show run section OSPF. Okay, so this time we're going to configure on the ABR, my fault. We're going to configure area 10, not so stubby area, but also put the command default information originate. That means that router 3 is also going to give out that default route, but you've got to specify it. And now if you look at the routing table for router 10, we've also got this default route now, okay, which is going to get us to the external ones. And if we try that ping one more time, it's now going to work. So just remember that when you're configuring a not so stubby area, we're not going to actually allow the default route by default effectively. You're going to have to explicitly configure it, because OSPF doesn't want to make the assumption that you're definitely going to want to default all your traffic into the OSPF domain. You need to explicitly tell it that's your default way. That's the default way you're going to have the path, have the traffic go effectively. So to recap, a stub area will remove the Type 5 LSAs and the Type 4 LSAs, but it will still allow the Type 3s. However, if we actually want to allow our own locally connected Type 5 LSAs, we need to do a little bit of a trick and introduce them as Type 7s. And the way you do that is by configuring the stub area as a not so stubby area, so you can get the benefit of removing the Type 5 LSAs from external parts of the network, but ones which are actually connected to you, you can actually allow them to transit in and be introduced into the network, and that really is the function of a not so stubby area. So that's pretty much the end of the video. The next one's going to be on a totally not so stubby area, and that's it. So thanks very much, and I'll see you guys soon.